Alright, so now we're going to look at how to find the mode for group data. So we have marks and number of candidates. So as I said last time, depending on what you've been given, but for practice, however, you're going to be drawing all the columns. You're going to draw all of them as we are. When you reach mode, you're going to see more. You do medium, you will see more. So in your practice, you will do everything, include all the columns, just to make you better. But however, let's say in a paper, you just have to include the columns you need and the rows to solve that number. So here I have this into a class interval. Now, some of us by now may not be understanding what this is, and I'm going to explain it in a bit. So I'm going to put here marks. This is 50 to 59, I have 60 to 69, 70 to 79, 80 to 89. Okay, we have this. Then now number of candidates, I can even call this frequency. Actually, not I can, it's the frequency. 24, this is 8. Okay. Now, the frequency, I'm going to use it to find the delta 1 and the delta 2. So I need C is the class interval. I need a column for the class interval. However, class interval can also be is called just C for class interval. So I come and say 59 minus 50, that's 9 plus 1, that's 10. 69 minus 60, 9 plus 1, 10. So if this makes sense, 10. Now I have to include the class boundaries. Why? Because L1 is meaning the lower limit of the model class, and of course we are going to have that in the form of the class boundary. So we said 0.5 times 10 to power negative n. Here the number of decimal places is 0. It should be 0.5 times 1, which is 0.5. So minus 0.5 here, I'll get 49.5 to 59.5. Then here I'll get 59.5 to 69.5. Then 69.5 to 79.5. Then 79.5 to 89.5. So we have this, and now note the thing we said about class boundaries, they are continuous. So you see this is continuous with this, it's continuous with this, this is continuous with this. Okay, now let's now look at the mode. Now the mode, actually the definition of mode naturally is the mode is the highest occurring number. So if I had something like 2, 2, 4, 5 and I asked you what's the mode would be 2, because 2 is occurring most. However, now here we have it in terms of frequency, like the number of students that are in a specific range. Now, knowing just that here the marks or the which have the highest number of candidates, it's 24 candidates who are having between 70 to 79. But now the mode cannot be a range. The mode has to be a specific number. But however, we call this the model class, because this class specifically, because I told you we call these classes, then when we change they become class boundaries. So now this class has like the highest number of students, so we call it the model class. Now as you work out all the numbers and you're getting mode, usually the first thing should be to find what's the model class, and you have it at the back of your mind. So this is the model class. You see, this is the model class. Or like, yeah, so this is the model class. Now we are going to move on. So we want to find what is the L1. We said L1 is the lower limit of the model class, so we can already pick it out here. This is the model class. We just see what's the lower limit, 69.5. So you see how not hard this is. Then how do we find delta 1? Delta 1, we're going to find it by saying the highest frequency, which is 24, minus the frequency before it, like the frequency just above it. So it would be 24 minus 10, and this gives us, I think this gives us 14. Then we come and say what is delta 2? The highest frequency minus the frequency below it, or the frequency after it. So here we say 24 minus 8. 24 minus 8 is going to give us 16. So we found this, we found this, we found this, we found this. Now what are we left with the C? We just pick it from here, 10. That's why I told you should always include the column for class interval when you're finding the mode. Even when you're finding the median, you don't only include when you're finding the mean, but when you find the mode, median, you include it. Now we just have to substitute. Our mode is going to be L1 69.5 plus 14 out of 14 plus 16 times C, and here C is 10. Now here usually many students fail this because of how they use their calculators. So advisably, first break this down. So this is 69.5 plus 14 out of 30 times 10. Now for some people, you can now put this into a calculator first, break this down, then you now add 69.5. That might be the easier way. Also another thing about rounding off, usually we round off to 4 decimal places. Let me actually say now, round off to 4 decimal places for all other numbers that are not degrees. For degrees, we round off to 2 decimal places. However, when rounding off, you have to round off from something. You don't just pick your value from the calculator, because the examiner doesn't know that you round it off from the calculator. I don't know if you get what that means. It means you're supposed to show the examiner a picture of the original value you had, then now you round it off to 4 decimal places. Though, as we are doing numbers here, many times I may not do it, but it will just be a culture. You should get that as you're doing the exams, you should always round off to 4 decimal places, but try to show the examiner a picture of that what you got on the calculator. Here on the calculator I have something like 674.16666. It continues, but let me round off to this. So this is to how many decimal places? 1, 2, 3, 4, 5, 6, 7. 7 decimal places. So still I've rounded it off, but I've picked a bigger value. Now I can come here and I'll say mod is equals. Now I'm rounding it off to 4 decimal places. 1.667% to 4 decimal places. Now what I was meaning was, now someone may just come and pick this value and put it here, that mod is this, but I was saying you should try to show the examiner what the original value, that I'm rounding it off from a value that somehow like this to this 4 decimal places. I hope that makes sense. Though as I've said, as we practice many of the times, I may not necessarily keep doing this just because we are focusing on understanding the other concepts, but this should be something that should stick. So especially for when we are covering numerical methods, it's actually now very important. It's very penalizable there. Now let's do the median. And now these examples, I'm trying to do them such that they can cover everything. Then in the exercise, I'll just be showing you the solutions, not having to work out the numbers, because it will take a lot of time. But if you understand this, I think you've gotten most of the concepts. So here we'd have n out of 2. I said mastering this formula is going to be very important for you in this topic. And why am I writing this? I want it to guide me on what columns and rows to include, as I said. But for you, for now, for all the numbers, try to do everything. Maybe you get a number, do the mode, do the median, do the average. We're going to look at standard deviation in a few. Do the standard deviation. So it's a means for you to practice. But now this is when you're in a paper and you can't afford to write things that may not be needed. Though still no one can penalize you for adding extra columns, but just to save time. So here I need to add a column called the cumulative frequency. Now the cumulative frequency is like we are summing up the frequencies, want to combine them, and at every point we add the next. You know, if I say, okay, I have 3, and maybe here I have, okay, now let me explain it from here. So for the cumulative frequency, we are going to keep adding, we're accumulating. The cumulative means we're adding that. It's like when you score marks. Let's say in midterm you had 30, in end of time you had 41, in maybe next time midterm you get 650, then here you get 71. Then now, for if I was just doing these marks independently, each of these would be independent marks. But usually many school systems want to have a cumulative performance of the child, such that it's easier to know, because some people maybe wake up in the last term and yet they have not been performing well, so they say they're going to, and even some people perform well at the start, but at the end, towards the end, maybe they get a health issue. So this cumulative coverage helps you get a bigger picture of whatever is happening. I hope you get what, in a sense, what it means. Here, this student had a 30, a 41, a 50, a 71. Let's say now in third term they become very serious. They get 89 and 90. So you see, if you only looked at this, it would in a way make you think, okay, this child is very serious. But when you come and look at this, you see it's not the exact bit. So in cumulative, if this were to be cumulative marks, we would keep adding. Maybe we add this, we get the average. Add this, get the average. We add this, get the average. But even here, we now add everything and get the average. So the mark we shall get will be giving us a picture of almost everything that's happening. Now this is not the exact concept in cumulative frequency, but I'm giving you a picture. In cumulative frequency we are adding, because here we are actually getting the average, but in cumulative frequency we actually just add. So now here, for the first thing it's 8 because there is nothing to add, it's just starting. Now to get the next cumulative frequency, I get 8 plus 10, I get 18. 18 plus 24, I hope you're seeing what we're doing. Here I get 42, then I get 42 plus 8, here I get 50. Another clue on the cumulative frequency, the last value in your cumulative frequency column should be the same as the total number of students. Here they are 50, so you see 50. Even if you say the summation of f here is 50 when you add everything, so the last value here should always be equal to the summation of f. That's the cumulative frequency column. I hope it makes sense. Now let's move to, we have the frequency, we have this. I won't show you how to get this. We now just need the class boundaries and we are good to go. Oh, we can also put the class interval. So I told you the class interval can also be called C. 59 minus 50, we get 9 plus 1, 10. But here we already know that this has equal class interval, so that's why I've just put this. We've been doing this number for like since the previous part. Now I can move to the class boundaries. 0.5, though when you see that a number has 0 decimal places, you don't have to even do this, you just know it's 0.5. But now the trick, it becomes tricky now when you have more than 0 decimal places. That means when you have like 1 decimal place, 2 decimal places, you have to do this and find out. So this would be 49.5, 59.5, 59.5 to 69.5, 69.5 to 79.5, 79.5 to 89.5. So these are our class boundaries. Now let's go ahead and find the median. Now the most important thing when you're doing the median is this n out of 2. So we can pull it out now because it helps us find the median class. Remember, the median is the number occurring in the middle. When we were working out the median in ungroup data, we had 2, 3, 4, 5, maybe 8. We said arrange them in ascending order, then you pick this out. You do this, the one in the middle. So that's why even you have n out of 2, we are like, trying to get the number in the middle. And what is this n? The summation of a, 50. So this is going to be 50 divided by 2. So this would be 25. Now this 25, you come with it on the cumulative frequency. You come with it to the cumulative frequency. This is the cumulative frequency column. And you look in the cumulative frequency, which number is just above the n out of 2. So here 8 is not above n out of 2, it's actually below. 18 is not above, it's below. 42 is above, and it's the number just above, because even 50 is above 25, but this is the number that is just above. So even if I had 26, I would actually choose 26. But if there is no 26, any number just above 25, whether it's 27, because just being whether it's the number here, I don't know if that makes sense. Now when you choose, for example, here when you have this 42, the column that includes 42 becomes the median class. Remember last time I was telling you about the model class, and many people actually think that the L1 for the model class is the same as the L1 for the median class. Sometimes, or many times, it's the same, but how we find it, they are different. Hope that makes sense. So this is what we have here is the median class, and it's what we are going to use to fill in here. So median is going to be equals to L1, which is 69.5, the lower limit of the median class. And I told you, usually coincidentally they are the same. You look at this, even here we had 69.5, But how we came up to this 69.5 is different, because here we are using the frequency, the highest. Here we have used the n out of 2. Hope this makes sense. Plus n out of 2, which is 25, minus the cumulative frequency before the median class. So we come here, this is 42, but the cumulative frequency before this class is 18, so minus 18, divided by the frequency within the median class. So if this is the median class, the frequency within the median class is 24. Hope this makes sense. 24 times the class interval of the median class, which is 10, so times 10. I told you now, many bright students now lose it from putting these values into the calculator. So it's usually healthy that you break it down and do it slowly. So now you can say 7 out of 24 times 10 first in the calculator, then you add this, and as I told you, first put a big value, maybe round it off to like 6 decimal places, then you round it off to 4. So here the median is going to be 72.4167, the units percent to 4 decimal places. Hope this makes sense. So here we found our median. Now we're going to look at something called variance and standard deviation. So I think after variance and standard deviation, we can briefly look at quartiles and percentiles, but we won't actually go in details because the quartiles and percentiles resemble how we find the median, and the video shouldn't be very long. The goal is that you understand, get a proper background for these concepts. That's the main goal of this video, that by the time you finish the video, you're good to go. Now, the variance, finding the variance for ungrouped data, for grouped data, sorry. Our formula is going to be summation of fx squared out of summation of f minus the mean squared. So meaning here you have to have your mean from above, and if you've been following, we already found the mean. So I'm just going to quote it. I'm not going to calculate it again because of time. Now I'm going to have a column for max, I'm going to have a column for frequency, I'm going to have a column for the x, I'm going to have a column for the fx. Now I told the frequency, I'm going to copy it from here. The x, I'm going to add this plus this, divide by 2. So then fx, I'm going to multiply here times here. So I'm going to pause this video and write this very fast. Okay, now this is here. We had this column in when we were doing the mean. So here, why are we going this way? Such that we can add a column for f of x squared. So I hope you see how I'm doing this to avoid, to reduce the chances of making errors. That's why I've done fx, because someone would just say, why don't I just go to fx squared? Having the column of fx would reduce the chances of error, because here I'm just going to say this times this. So here I'll say this times this. So you definitely have to use a calculator here. This is 41,602.5. You have 133,206. Then you have 57,122. So you have this, then you get the summation of fx squared. So carefully in a calculator. Now here, another common reason why people see all students fail this is because they don't know how to use their calculators properly, or they're in a rush and they don't get it well. So you have to be slow and proofread your work, like try to check for errors, because it's very easy to make an error with one digit and everything here would be wrong. Minus the mean squared, the mean is 70.9 squared. So part of what makes a good mathematician here is ability to avoid making errors in your calculations. Now sorry, I didn't even talk about why we need the standard deviation, why we need the variance. It shows us how students are spread about the mean. Like now here, when you look at this, our mean was 70.9. Like we want to see how our students spread about this mean. So here when you see it's 87.04, it means the students are spread around this. So let's say if this is the mean, we are like around here 80.87.04. That's how students are spread about this mean. And as you can see, we don't even have the extreme max. We don't have students who are below 50, we don't have students who are above 90. So most students are Hope that makes sense. Though of course no one is going to ask you that. Now standard deviation is going to be equals to the square root of the variance. So usually you find the variance and you find the square root of the variance to give you the standard deviation. So here you get this 87.04. It's going to be, I don't think this is the unit for variance. So it's going to be equals to 9.32952303. This is to 8 decimal places. Then now here you can round it off to 9.3295. This is to 4 dps. This is the standard deviation. So after this, we've looked at mean, mode, median, standard deviation, and variance. So that is clear. We're now just going to add a bit of talking about quartiles and percentiles, and that's going to be it. So thank you for following this far. Let me